away. So on this video we are estimating sets. Yeah, well, cool. I wrote something very powerful here. So we are saying if the nth root of a number cannot be simplified to a rational number, we call it a surd, right? So the nth root, right, if you have if this is the nth root, right, if you have a number like this and it cannot be written, right, or it cannot be simplified as a rational number, we call it a surd, right? So that means what from what we have done, we know that this number we cannot write it or we cannot simplify it into a rational number. So that means we will call it a what? We're gonna call it a surd. Wow. Cool. So let's see what we have. I made some examples there with the square root of 2 and yeah, that guy over there. Cool. So the main goal for this video, the reason why we are making this video, so that you are able to approximate what one other said without actually using a calculator, right? Good example, you have a set, any particular set, right? Maybe I don't know, this one, you see this number here. Say you're trying to approximate on your number line, plus or minus, where will it be? You can do that without using a calculator, right? Of course, you cannot give me the decimal number of this number without using a calculator. Like, you have to use a calculator, but there's a method that we can actually use where you are able to approximate where in our number line is it going to be. All right, so we will deal with that in a few. So of course, one thing that we need to understand is that, yeah, if a is smaller than b, right, the nth root of a is going to be smaller than the nth root of b. So long as a is smaller than b, right, then this is the case. And of course, both a and b, they are positive whole numbers, right? Or we can just say they are natural numbers. All right, so cool. We have a number here, 26, right? We have a number here, 26. Let us think of a perfect okay, let us think of a number, a square root of something, right, that is closer to 26. Ne? I think verbally I'm failing to put this in the right way, ne? But I think with examples you will see what I'm actually trying to say. So we have square root of 26, you know, you have also what you have square root of 25, which is what, which is 5, ne? And then after here, right, after here, the following, right, square root that we know is square root of 36, right? Square root of 36, right, which is what, which is 6. Do you see? So therefore we can then say, remember now we did say that if a is smaller than b, therefore nth root of a will be smaller than nth root of b. You remember this, ne? So now we use that idea to say, okay, since 25 is smaller than 26 is smaller than 36, therefore square root of 25 is smaller than square root of 26 is smaller than square root of 36, implying that you have 5 square root of 26 and 6, right? So you now know this number, square root of 26, it has to be between 5 and 6. So In that case, it's going to be 5 comma something. Let's check it. Square root of 26, 5.00990. It is, that's the main thing. It is between, do you understand? Cool stuff, cool stuff. So now let's go and think again. We have this number 16. Which numbers are we now thinking of? Let's think. So it's a square root, né? So you have 1 giving you 1, you have 2 giving you 4, you have 3 giving you 9, you have 4 giving you what? 16. Why did I put this number there? Yeah, well, I don't know, because here, of course, the answer is going to be what? The answer is going to be this is 4, right? This is 4. So I don't know why I put that there. So let's let's move on. So beautiful, 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 beautiful. I just want to check also 81. Cool. No, this is beautiful. So now look at where we are, né? Cube yeah. So we have a cube root there, right? We have a cube root of 81. So we now have to think in terms of the cube roots. Now, I know I can start from 60. Let me start from 60. Okay, 4. I know 4 to the power of 3 gives me 64, right? It gives me 64, right? But how about 5? Yeah, how about 5? 5, it gives me 120. So then I have my numbers, right? So then I will say, because then you see 4, 5, right? So now I will say what will I say? I'm gonna say 4. Okay, how do I say this? Okay, this is 64 is smaller than 81, is smaller than 125, right? Therefore, square root of 64, no, cube root of 64 is gonna be smaller than the cube root of 81. It's gonna be smaller than cube root of 125, and therefore you have 4. So you know this number is between 4 and 5. You see, here is the other one. Beautiful enough, is the one with the cube root. So you see here we have a cube root of 123, né? 125 is above. So from here you already see 123 is smaller than 125. That means we can also put 64, right? And the same logic will then fall to say this, and then you have your numbers being between 4 and 5. Let's test them. Start with this one. Square root of 81. Not square root, man. Cube root of 81, right? It's 4.3, so it's 4 point something. Agreeing with our calculations here, that is between 4 and 5. Then let us look at this one. Shift 123. It's also between as well. It's very close to 5, but it's between the interval 4 and 5. Do you understand? So I think the last example that we have, it's a beautiful one. So we have these numbers here, and I want us to rank them in ascending order, right? Yeah. So the most important thing before we start answering the question is to ask yourself, what is ascending order? Ascending order, we are ascending, so we start from the smallest to the largest. We start from the smallest to the largest. Cool. So I'm gonna be more interested also on these numbers, the negative ones, né? Cool stuff. So I'm gonna deal with them one by one. Oh, and I actually said without using a calculator. That is beautiful. I actually said without using the calculator. Cool. So for these two numbers, ne, they are both negative. Let me work with the first one. This one, and we have 3 squared over 2 squared, negative, right? And this is just going to be 3 over 2. So this is negative 3 over 2, which is negative 1.5. You see, so this number here, because we have a square root of, okay, let me do it step by step, right? I'll do it step by step and say here what we have. We have negative 9 over 4, which is square root of 9 over square root of 4, which is 3 over 2, right? So this is gonna be negative. Do you understand? And that is actually negative 1.5, right? When we focus about this one, it's what number is it going to be? Cool. So you see now I'm stuck. I don't know what number that is, right? From head I know it's 2 square root of 2, ne? Let me show you. Yeah, square root of 8 is 2 square root of 2, but I don't know what square root of 2 is, and I don't know what it means. I'm going to guess. I didn't see the decimal number because they say without using a calculator, right? So I'm going to apply exactly what we have just learned right now. Square root of 8. Ne? So I will think of numbers. Ne? I have 8 smaller than what? 9. And then we have smaller than what? 2, which is 4, right? We have these numbers, yeah? And then we go again and say, therefore, square root of 4 smaller than square root of 8 smaller than square root of 9. That means we have 2 square root of 8, we have 3. So this number is between 2 and 3. Do you understand? So now when we are talking about it in a negative form, therefore it's gonna be between negative 2 and how will I say it? Yeah, it's gonna be between negative, let me say negative 3 and negative 2, right? It's gonna be between those two. So that means between this number and this one, this is the smallest one, and then follows this one. So if I write it down here, I'm gonna have negative, let me go black, negative square root of 8, then negative square root of 9 over 4, right? So let's go back. I will remove everything and let's think what numbers are gonna come next, right? Cool. I am thinking, right, I want to see what this number, I want to see what this number is, this one, as well as this one. So I will start with the 19, eh? I will start with 19 to say 19. I'm sure I have 25, and this is going to be 16, right? Then I do this all over. Then I have 4 square root of 19 square root of 5. So this number is between 4 and 5. Ne? Let me go. This one, 51. Ne? 51, I am thinking after 51, we have, okay. Let me say I have 49 here. That is for 7. And then 7 squared is 49. 8 squared is 64. 64, right? We have this and it's all fine, right? Then we put our square roots all over, and then we have 7, 51, 8. So this one is between 7 and 8. So I'll just say 7 and 8. um it's between, and then this one it's between 4 and 5, so I'll say 4 5. Yeah, beautiful, beautiful work, beautiful work. So let's go. Whoa, whoa, whoa. Okay, cool. um cool stuff. So what I know about pi, let's go here. Pi, I know it is 3.14, right? I forgot the number that comes, I think 5, right? But this is the pi that we all know. So you can just say 2 times this, which is going to be 6.28, right? So 6.28, 6.28, you have the number there. I'm thinking we have 6 is fine. So this one is sorted, 6 is sorted, this one is sorted. We're gonna deal with these two. Sorted. Let's go here, right? These ones, they will just be the last numbers. So if we go here, we have 27 divided by 7 is equals to, so now we check how many sevens do we have in 27. 7, 14, 21, 28, right? 28. So that means we have 3, right? We have 3. And so how many are them? It's gonna be 3 comma. So now 7 times 3, it's 21. So 27 minus 21 is 6, right? 6. So we have 6 over 7, and then yeah, so cool. I'm gonna pause here as well. So I'm gonna pause here as well. So the reason I'm pausing here is I know that my number is gonna be 3 point, a couple of numbers coming after here. You can go on and try to write this as a decimal number, right? But remember, we're just trying to rank these numbers. um yes, we are just trying to rank these numbers, and we don't have any 3 point something. So this is gonna be 3 point something. So now we have these two. Now the first one is 0.45, then the one that follows after is 0.4545. Now, so you, of course, you can see that this one is bigger than this one, right? So 0.45 is greater than 0.45 recurring. What am I saying? No. Yeah, this number has to be smaller than this one, right? Because of course here you have 0 0, 0 0 smaller than 4 5. Cool. So it makes sense, so you have this one, this is the smallest, followed by this one. So when you go now to our, let me bring it up. Cool. So now when we put this number, we have negative square root of 8, we have this one, and what's going to follow now, we are done with negative numbers. It's going to be this guy over here. We have 0 0.4, let me make it a full stop, 45. Then we have 0 0.45 recurring, and then we go 1 2 3. So we're gonna go here 27 over 7, and then we're gonna go here square root of 19, and then after square root of 19 we have 6, then we have 2 pi, then we have square root of 51. I just want to see if we have everything. 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9. Yes, we're done. Yeah. So of course, like I was saying, the whole idea was just to write them as um yeah, the whole idea was just to write them as fractions. What am I saying? The whole idea was to write them in order from the smallest to the biggest. Cool stuff. Yeah. So I just wanna talk about this one. When I was looking at it initially, that time I had forgotten actually how to change these numbers into decimal. So we're just gonna do it right now. So first and first is just like I did. We have 3 27s in 27, so it's gonna be 3. Then since there isn't any other comma, and then you're gonna be like, okay, 3 times 7, 21. 27 minus 21, that is 6. So now you have 60 divided by 7. Now you check how many 7s you have there. You have 8 of them. 7 times 8, 56. Right, 56 minus this number, 56, it's gonna be 4, right? So you continue, go on and like it's gonna be 40 then over 7. So how many 7s you have? 40, 7, 14, 21, 28, 35, 35, 40, 2, 42. So that means you have 5 7s. So we go 5. Yeah, actually when I punched this in a calculator, then it started to make sense to me. Yeah, but that's not what we are covering in this lesson. Yeah, cool guys. I'll see you in the next video.